Welcome back to my channel. Dear student, I know that you are much curious to know about our home planet Earth. So today we will start our new chapter of geography, our changing Earth, in which we will see the following topics. Topic number 1, introduction of the chapter. Topic 2, evolution of landforms. Topic 3, volcanoes and earthquake. Topic 4, major landforms. So let's start the chapter. Students, you have read that the earth was formed millions of years ago. But according to the geologist, the world map at that time was completely different from its present form, as you can see in this picture. Various external and internal pressures have gradually changed the form of the Earth's crust. The Earth's crust consists of several large and some small, rigid, irregular shapes, plates of slabs, which are called lithospheric plates. These plates keep moving, but the movement is very slow, just a few millimeters each year. This is because of the molten magma inside the earth, which moves in a circular manner. The movement of these plates cause changes on the surface of the earth. These movements are divided on the basis of the forces which causes them. The forces are of two types: endogenic force and exogenic force. Forces which affect the earth's surface from its interior are called endogenic forces. Endogenic forces can be classified as sudden movement and dystrophic movements. Endogenic forces cause sudden movements of the earth's crust. These movements may lead to earthquakes and volcanic eruptions. Dystrophic movements cause changes very gradually, which might not be visible during a human lifetime. Dystrophic forces refer to forces generated by the movement of the solid material of the Earth's crust. They also cause land folding and faulting, as well as elevation, mountains and depression, rift valleys of lands. Number 2, exogenic forces. Forces which affect the earth's surface from outside are called exogenic forces. Exogenic forces that wear down the earth's surface crust from outside include weathering and erosions. Students, as I told, endogenic forces sometimes produce sudden movements and at the other time produce slow movements, sudden movements like earthquake and volcanoes. So first we will see the first sudden movement, volcano. A volcano is an opening in earth's crust from where molten magma, ashes, gas and steam are emitting with a sudden force. Molten magma lies under great pressure inside the earth. When this magma reaches a weak point or a crack in earth's surface, it comes out with great force. Molten magma, which erupts from a volcano and falls on earth's surface, is called lava. The tunnel-like part of the volcano through which lava and other molten materials are emitted is called a vent or shaft. The vent has a large cup-shaped mouth called crater. According to the frequency of eruption, volcanoes around the world can be divided into three categories. Number 1, active volcano. Number 2, dormant volcano. And the number 3, extinct volcano. The eruption of a volcano may lead to earthquakes too. Most of the volcanoes occur along the Ring of Fire, which runs along the edges of the Pacific Ocean. When the lithospheric plates move, the surface of the earth vibrates. The vibrations can travel all around the earth. These vibrations are called earthquake. Earthquakes are vibrations in the crust of the earth. The point in the interior of the earth from where the earthquake originates is called the seismic focus. These moves from the focus in all directions. The point directly above focus on the surface of the earth is known as the epicenter. The intensity of an earthquake is measured with the help of an instrument called seismograph. For the measurement of the intensity of the earthquake waves, Richter scale is used. Although earthquakes cannot be predicted, the impact can certainly be minimized if we are prepared beforehand. Some common earthquake predictions methods adopted locally by people including studying animal behavior. Fish in the pond get agitated. Snakes come to the surface. Students, here I am providing you a case study of earthquake which hits Bhuj in Gujarat. Now let's move to our next topic, major landforms. The landscape is being continuously worn away by two processes, weathering and erosion. Weathering is the breaking up of rocks on or near the earth's surface by alternate heating and cooling, by chemical action, by burrowing animals and growing roots of plants, and also by human activities such as plugging, digging, and mining. Weathering does not involve transport of rock material. Weathering is of three types: physical weathering, chemical weathering, and biological weathering. Number 2, erosion. In the daytime, rocks get heated under the sun, and at night they cool down. Because of rapid and repeated heating and cooling, rocks develop cracks. These cracks widen further and finally rocks breaking into small pieces. Small rocks fragments are easily removed by the agent of nature as wind, water, and ice. This process is known as erosion. So here we will see some major landforms which are formed by the weathering and erosion. So first of all, we will see the work of a river. River is one of the important agents of change. Water wears and tears the rocks on its way and transports the loose and unconsolidated material known as silt throughout its course and deposit it near the mouth of the delta. A river can be divided on the basis of the courses followed by upper course, middle course, and lower course. As you can see, figure number 3.4, a waterfall. It forms where the alternate layers of hard and soft rocks are found. The swirling action of water cuts away the underlying soft rocks more easily than the harder rocks laying above. Thus, stream starts to flow here and waterfall forms. Niagara waterfall is the world's famous waterfall. In plains, the river moves in a leisurely way. Its course forms broad, S-shaped bends called meanders. Sometimes the curvature becomes so sharp that the river breaks through the bends and forms a loop known as Oxbow Lake, which you can see in this given figure 3.5. The rich deposits from the overflowing rivers also flatten the land around the banks to form fertile floodplains. And the raised banks are known as levees. Rivers form the delta after reaching to the sea or an ocean. It is a landform which is formed at the mouth of the river where river discharged all its water into sea or an ocean. A delta is triangular in shape as is appearing in your screen. For example, the Ganga-Brahmaputra Delta. In India, the river Ganga, Brahmaputra and Meghna form the largest delta in the world called the Sundarban Delta. It extends over more than 260 km along the Bay of Bengal. Now let's move towards the work of sea waves. The work of sea as an agent of denudation is known as marine action. It involves erosion, transportation and deposition of debris created by sea waves. It gives rise to coastal landforms. A sea cave may develop at the base of cliffs which have been subjected to the action of waves over a long period of time. It is a cylindrical tunnel which extends into a cliff. Sea arcs. When waves erode sea caves, they get larger and larger till only their roofs remain. Such features are called sea arches. Stakes. When the arch breaks down the rock column that remains is called the stake. Sea cliff. Sea waves erode rocks along the coast to form steep rocks, faced or cliffs that rise almost vertically above the water. Marine cliffs are formed in this way. The sea waves deposit sediments along the shores, forming beaches, sandbars, spits, and lagoons. Now, work of ice. The large blocks of ice that move forward under their own weight are called glaciers. These can be found where snowfall is high, such as high mountains like the Himalayas or in the polar regions like Antarctica. It is believed that 99% of all glaciers are found in Antarctica and Greenland. A glacier is thus a river of ice. Like river water, the ice of glacier picks up the transport large amount of material called moraine. The glacier forms steep-sided wide valleys which seem to be U-shaped. These valleys are called glacier troughs. The glaciers of the polar region are ice sheets thousands of meters thick. Often, huge blocks of ice break off and drift into the open sea as icebergs. Now, let's see the work of wind. Wind is also an active agent of gradation. It is an agent of gradation in deserts. Due to the lack of moisture and vegetation, the soil particles are blown away by the wind from one place and get deposited in some other place. Features formed by the wind, erosion and depositions are known as aeolian features. Winds carry heavier rock fragments at a lower level. So when wind hits a mass of rock, it tends to erode the lower part of the rock more than the upper part. This gives the rock a shape resembling a mushroom, such as rocks are called mushroom rocks. When it stops blowing, the sand falls and gets deposited in low hills like structures. These are called sand dunes. Sometimes sand is carried away to a distant location that is not a part of the desert. Sand is deposited therein and create a unique structure. These structures are called loess. The large deposits of loess is found in China. The whole process of weathering, erosion, and finally deposition of the weathered material to different locations create different landforms on the surface of the earth. So students, here the chapter is complete. Here are some definitions which you have to do in your notebook. Number 1, endogenic forces. Number 2, exogenic forces. Number 3, volcano. Number 4, epicenter. Number 5, weathering. Number 6, erosion. Number 7, deposition. And number 8, lithospheric plates. So students, here the chapter is complete. Hope you understood this. For more videos, keep watching SST Zone.